Welcome to XL Catlin Arctic Live, broadcasting from the UK Arctic Research Station here in Ny-Ålesund on Svalbard, and welcome to the open Q&A session. This is where we will try and answer as many of your questions as possible, both those that have been submitted in advance and those that come up on the live chat on the Digital Explorer YouTube channel. So Arctic Live has been a great 2 weeks. We're on the final day today. I can't believe how fast it's gone. We have been doing science up here. We have been looking at microplastics in the fjord, and those are just out here. We'll go outside maybe in a bit and have a look at where we've been sampling. We've also been looking at ocean acidification, and that is where carbon dioxide in the atmosphere absorbs into the ocean and changes its chemistry, both looking at how fast or to what extent the waters here might be acidifying, as well as its potential impact on some of the life in the ocean. But for this open Q&A, we'll be taking your questions and seeing how many we can get through in our session. Do join us. We have 3 more sessions if you're still at school, or for those schools in North America. We have a live investigation into sea level rise. We have an interview with Ellie Mackay later today, as well as a final open Q&A session this evening. I think Ellie's just going to come round and we're going to work through some of your questions. A very big welcome to schools in the UK, USA, Belgium, Nigeria and India, and we have questions in advance from Richards Catholic College in Bexley-on-Sea, Anthony Gell School in Wirksworth, West Monkton Primary School in Taunton, and Hawkley Hall High School in Wigan. Welcome one and all.
Fantastic, welcome everybody. So we've got lots of questions to get through, so we'll get cracking straight away. So starting off then with Jules Durkin's class, and that's at Richards Catholic College in Bexley-on-Sea. And their first question, which is from Harry, would like to know, how did you get to be a polar explorer?
Wow, well, I wouldn't go so far as to say I'm a polar explorer. I do know some people who could probably call themselves polar explorers. But this is my 7th trip to the polar regions, and I have been working with science teams in the main part and helping them communicate what they do to a wider audience. How did I get that job? I'm not quite sure. I think a number of years ago I knew how to operate satellite equipment. I taught myself on a previous trip. I was fairly comfortable in cold places, having spent 2.5 years living in and travelling around the Himalayas, and I could just about hold the camera. So I think that's what got me on my first trip, and then it's a very sort of niche set of skills to have, and then you get invited back again and again. If you are interested in the polar regions and you are interested in coming up here and working up here, then some of the best stuff you can do is just get into the outdoors, whether that's sort of with friends or with family, or as part of a more formal scheme, such as the Duke of Edinburgh scheme.
You can't just wander up here on your own, can you? Not advisable.
Not advisable to wander up here on your own, no.
And so Harry, I believe it was asking, about polar explorers. But how would you define an explorer?
So we have, crikey, it's a good question. In some ways it's a rather antiquated term, I think in general, but it sort of describes a sort of rag bag of people who are curious about the world, really. And I think in the modern day and age, explorer can encompass scientists who are discovering more about remote parts of our world, and other researchers from the humanities. It could cover filmmakers and communicators and journalists who are also doing that, who are also going to far places and finding out what they're like and recording it and bringing that back. And also to those adventurers who want to push themselves to the limits and who are drawn by the call of the wild.
Brilliant. Okay, thank you. And Lily would like to know how we do experiments in extreme cold conditions.
It's a really good question. So a lot of the experiments we're doing are this year are connected to the ocean, and it really is about picking up the samples here. In terms of the cold weather, it hasn't really been that cold this year. The temperatures sort of hovering around freezing around 0 degrees. But in previous years, it can be tricky because you bring some seawater samples out of the sea. They can start to freeze really quickly. So that makes life very difficult. You always have this weird balance of things that are frozen that you need to melt, or things that aren't frozen that need to be frozen, and things that can't be unfrozen and need to be at a certain temperature. So very weirdly, that was Lily, was it?
Yes, yeah.
Very weirdly, Lily, we also have freezers in the Arctic to keep our samples at constant temperatures. So it is complicated, not only because it's cold and you need to kit up and get your sort of proper clothing and equipment on, but also because your samples can freeze and unfreeze and do all the wrong kind of things.
So related questions there, moving over to West Monkton Primary School in Taunton, and this is Janet Ross's class. Harriet is asking what's the coldest temperature it's been while we've been here, and what about in general, what's the coldest you've experienced?
Oh, okay. The coldest temperature we've had here, I think it was -10 or something on the first day. We've had one day where the wind chill's taken it down to -15. The coldest temperature I've been at has been -48, and then with wind chill, I think at -59 or something.
Gosh, and so I've got another question that's linked to that, which is from class 7F1 at the Anthony Gell School. What does -40 feel like, and how long can you survive in those sorts of conditions?
So I think we had a good few days below -40 or below on my first trip in the Arctic, and we were living in unheated tents. Our kitchen tent was heated, and some of our lab tents were heated, going back to that problem of things melting or not melting and keeping things at the right temperature. And so what does it feel like? It hurts, so you ache, you're in pain. It can be sort of gnawing, aching, biting. Sometimes I say, if you want to know what -40 feels like, just don't do this. This is a sort of like there's an advisory notice. Do not do what I'm about to describe. So get a fork, get a freezer. Turn your freezer twice as cold, because a normal domestic freezer takes you down to -20. Get inside the freezer, close the door, and then stab any exposed skin with the fork, and that's pretty well what -40 feels like. And we're going to get into so much trouble if any of you try this at home.
Do not try that at home.
Do not try this at home.
Definitely do not try that at home. But very vivid imagery there. At least we can all imagine, perhaps, rather than actually doing it. We can imagine that painful sensation.
You probably imagine more closely sort of the fork sensation and the freezer sensation. Yeah.
Okay, brilliant. And the same question was also asked about how, what's the coldest temperature and how does it feel? That was also asked by Jordan at Hawkley Hall High School. So hopefully, Jordan, that's answered your question as well there. So then, from cold to heat, Sophie, and Hayley from Hawkley Hall High School, they'd like to know how warm is it in the station by contrast.
How warm is it in the station? I don't know. It's probably just pleasantly warm. It's not. What is it?
It's not
hot.
No.
Wow, either 10-15 degrees, something like that. So it is very pleasantly warm, and it's not like sleeping in a tent. And we do have hot showers. So compared to a trip where you're in a field camp, this is luxury being at the research station.
Absolutely. And sticking with the theme of luxury, what about food? We've had a couple of questions. So Dylan from Bexley-on-Sea has asked, how do we get food? And Class 7F1 have also asked, what kinds of food do we need to survive? So 2 different questions about food there.
Brilliant. So here on the base, our food comes in by ship, with a few fresh items being flown in by plane on a more regular basis. And it's really lovely food. Salads and bread is baked here, and curry we had for lunch, which was a curry we had a few nights ago. So what's really great is they keep on recycling and, you know, reusing the food.
So your dinner from last night maybe
lunch
mixed in with some fresh pasta or beans for the next day.
So very much limiting the waste up here. And what kind of food do you need? It's you know, if you're here, it's really easy, and you've got sandwiches you can make for lunch in the field, and you've got packets of biscuits that you can take out, and that kind of thing. If you if you're more remote, you might, or you're walking with all your food, you might want to do sort of higher calorie and lower weight food. So if you imagine choice, and this is where you need to think about calories as units of energy to eat. So you have a lettuce, lots of good nutrition and all that kind of thing, absolutely rubbish in terms of calorie for weight. So you need about sort of 8 tons of lettuce to get to the pole if you're walking, versus peanut butter, which has really got a really good
fat content.
Yeah, sort of calorie to weight ratio, and that's you're going to have far less peanut butter to get to the pole.
And it's how many kilos of peanut butter is it?
I think it's 60 or 70,
60 or 70 kilos.
would give you enough, or quite a few calories, and so enough to get 50 days on the ice or something.
50 days in the North Pole region. Yeah. And most of that, the problem with the reason that the lettuce you need so much is because most of that is water weight, isn't it? So a lot of the food that you take is dried,
exactly,
so that you're not carrying extra water weight.
No, and the way that you get water is that you take fuel with you. So fuel is very important because you can melt the snow to drink. Because
there's plenty of that around. Okay, brilliant. So good questions there about the food. So then back to Richard's Catholic College, and a question from Isabel. Yeah. She's asked, if you dug under the snow or the ice, what would you find?
If you dug under the snow or ice, you would find, at the moment, you'd find tundra in this area. And tundra is the name given to the type of soil and plants that grow here. We also have permafrost, so you do get thawing on the top layers, but then it's permanently frozen in the ground lower down. If you dug under the ice on a glacier, what we sometimes see in the fjord here is upside down icebergs. Well, not upside down icebergs, but icebergs where you can see where the bit that's been on the bottom of the glacier is facing up, and you can see that sort of like the sort of dirty, rocky sort of bottom side of a glacier stuck to the bottom of an iceberg. And you can also see as the glaciers retreat, there's a sort of rocky terminal moraines. It's a technical geographical term. You can see that. So pretty rocky, basically, is the ground around here.
And as that snow and ice melts going into the summer, then you might start to see a few tiny little shrubs coming up.
Yeah.
What sort of green plant life might there be?
So you've got a few grasses, you've got some flowers like saxifrage, and then there are a few tiny wee Arctic birches, which are not...
This is a tree that's about yay big?
Yeah, exactly, not that big.
Forests of birch. Yeah, not really forests, not really trees, are they?
Well, they are very much trees, but smaller.
Brilliant. Okay, so then what about what's the most dangerous thing that's happened on the ice base? Says Rory.
The most dangerous thing that's happened on the ice base. Wow. I think it's just the weather. Wherever you are. Storms coming through, cold weather. It's easy if you're further out. If you've gone out to a glacier research site, to become disoriented. The weather comes in, the ground contrast is really bad. And what I mean by ground contrast is normally if you're on the snow, you can see the sort of how the ground is sloping and the difference between the ground and the sky. When there's a very flat light and it is also cloudy and snowing, then everything just looks white. So you don't know where the edge of what a drop-off is. You don't know how the land is lying. You wouldn't be able to see any crevasses in front of you, and that can be really dangerous, especially when we're on skidoos or snowmobiles travelling around.
And sometimes you have to take it very slowly on the snowmobiles and sort of go a few hundred feet and then stop and get off and have a look and reassess and then get back on and go a bit further.
Yeah, sometimes not even sort of a few hundred feet. Sometimes it's just sort of 6-10 feet at a time, just to manoeuvre around until you find a sort of an easier way.
Slow and steady.
Yeah, very much so.
Brilliant. We've got a hello from David Fiederstein, who has asked on the live feed, what part of the Arctic are we in? So we've put a link there with a Google Maps, so you can click on that link in the live feed and see exactly where we're from, broadcasting from. But perhaps you could just describe kind of where we're situated in terms of where the Arctic, where's the North Pole, for example.
Yeah, so if you've got a globe and you're looking at the top of the world or a world map, and if you can find the top of Norway, part of Scandinavia in northwest Europe, and then Svalbard is between the top of Norway and the North Pole. So the North Pole, if you go out that door, you've got a bit of Svalbard to go, and then you've got a few hundred miles across sort of ocean and sea ice, and then you're at the North Pole. So north, east, south, west. So that's what we're facing. So that way to the North Pole, that way back to the UK.
And we're about 79 degrees north,
yes,
aren't we?
Just on
the border.
Yeah, so we're just under. I think we're at 78, sort of 58 minutes. 78 degrees, 58 minutes. If you're into your latitude and longitude.
Brilliant. And also on the live feed, got Ewan Hoyle, who's asked, what's the best piece of science you've found so far?
And the best piece of science, I mean, I think one of the interesting things is that this is only part of a longer process. So you sort of design, you have your question, you design your methodology, how you're going to answer that question. You come to the Arctic, for instance, you gather samples, you take those samples back to your university, you analyse them, you think about the results that you found from that analysis, and then you can start to think about what conclusions you can draw. You write all that up, give it to a science journal, so that's a bit like a sort of a professional magazine for reporting science, and it's done in a very formalised way. And then you might read about that you might read about that in a newspaper if it's considered important. And so we're at this stage here.
It's a very long process. How long might that process be?
It could be anything from 12 to 18 months, but it can be a bit shorter. It really depends. There's a peer review part of that, and that means when you send in what you've written, your article, other people who are doing similar research just check it just to make sure that they feel that it's all right.
So and that's something that's really nice about the scientific field, is very collaborative, and even though there may be perhaps even competing teams working on the same thing, they do all check each other's work and sort of give advice and compare and contrast each other's data. So it is very collaborative. You can't just publish something on your own that you've found without getting it rigorously checked. So it is a long process. And Ewan has also asked, what have you found hardest on the expedition so far?
Wow, what have I found hardest? I think what can be difficult on this expedition, like a lot of expeditions in the polar regions, are the weather delays. And so we had, quite early on, we had 3 days of storms, which meant that we couldn't get out to do some research. And that can make people slightly edgy, because So a lot of effort to get up here, and then if you think that you won't be able to do the science you came up to do, then it feels like a big waste, and it can get a little bit frustrating. But luckily, we managed to get everything done yesterday in terms of sampling, today in terms of deploying some experimental units, and now we're just packing our samples. So fingers crossed we get everything back to the UK safe and sound when we fly tomorrow.
And when you say deploying experimental units, that's something that's going out to gather information for when we come back next time?
Exactly, yeah.
So even though we're not here, we're still sort of leaving experiments running almost. So we're still able to gather data and come back and collect that in the future.
Perfect.
Yeah, brilliant. Okay, so back over to our pre-submitted questions, and we've got a question about what research are we carrying out. So maybe a little bit more detailed information about specifically on this trip. What are we looking at?
Specifically on this trip, we are looking at microplastics. So, are there any microplastics in this part of the Arctic Ocean? And if so, where might we find them? Might we find them in the surface waters? Might we find them in the deeper waters? Might they be in the sediment? Might they be in the animals? So we need to then look at taking samples from those different places, and then we can think about analysing those. We don't just think about it, we will be analysing those and starting to think about where those concentrations of microplastics are. The second piece of research that we're looking at is ocean acidification. So carbon dioxide in the atmosphere is absorbed into the oceans, and through a chemical process becomes carbonic acid, and that means the pH of the ocean is changing. So pH is our measure of acidity, and that lowering of acidity that's happened over the past sort of 250 years. So we've had a 0.1 unit drop of pH since the Industrial Revolution, and that represents actually a 30% increase in acidity. It
doesn't sound like much, does it? So it's decreased by 0.1, but could you maybe explain why that's sort of maybe more of a decrease than people might realise?
Because the pH scale is logarithmic. I'm not quite sure.
So each drop, 0.1, 0.2, 0.3, is increasingly more of a decrease. It's not a standard scale where each of those units is the same.
No.
So a 0.1 drop is about a 30% decrease.
Yes, that's right.
Yeah. Okay. So it's worse than it sounds.
Yes. So it's been a 30% increase in acidity since the Industrial Revolution, and that's affecting animals in a variety of ways, but especially those animals that have a calcium carbonate structure or skeleton. And so the reason for that is this change in ocean chemistry decreases the availability of the building blocks they need to make those calcium carbonate, a type of mineral, chalk, and the availability of that decreases when the pH goes down as well. So you've got examples might be clams or crabs or some forms of plankton up here. So measuring changes in the pH, or measuring the pH, we'll come again next year and see how the pH is changing. And then also putting down the experimental units, and that's looking at how the different types of animal that live in the waters here, the certain vertebrates, the small creepy crawlies, how their communities might be affected by changes in pH as well.
And leading on from that, the same class 7F1 have also asked, what's the most important research you've carried out, but why is this research so important?
So I mean, one of the reasons why, it's important in general to understand how we're impacting the planet. So these two bits of research are looking at human impact on the oceans. And in particular, we're looking at those in the Arctic for two different reasons, for the two different areas of research. For ocean acidification, that's happening here faster than at any other sort of point on the planet, really, because the colder waters here are acidifying faster, they're absorbing more carbon dioxide. Now, then for the microplastics, it's interesting because we're quite far from human habitation, so one would think that there shouldn't be any microplastics up here. So does the Atlantic current bring them up into the Arctic? And secondly, also interesting because there's some theories that the Arctic acts like a sink for plastics. And that's not, by sink, that means where they're all collecting. So you have sources and sinks where they start and where they end.
Okay, brilliant. Back over to the live feed, and Mr. Curtis has said, have we seen an Arctic fox yet?
I haven't seen an Arctic fox. There is an Arctic fox somewhere around. I haven't seen it, but have seen Arctic foxes in previous years.
Okay. And there's a good question here coming out of DPS in India. Welcome back. Thanks for joining us again. And they've asked, how many people are there living in the Arctic station? So they've said, we mentioned earlier that we have scientists from all different countries working on projects. So how many different people are there at the station, and do we collaborate on projects together? That's
a really good two questions. So there's 6 people at the UK Arctic Research Station at the moment. There are 101 people who are in the settlement here of Ny-Ålesund. And in terms of international collaboration, there is collaboration. Each group or research team has their own question that they're looking to answer. So it's quite independent in that way. But there will be collaboration. Maybe some of the data that we collect will be used by somebody else. We might collect some samples on behalf of another team. So there are those who collaboration, but we're not it's not a sort of joined up project, but lots of people helping each other.
Yeah, absolutely. Back over on the pre-submitted questions, and Lily in Taunton is asking, what do we live in while we're here?
We live in a wonderful research station. It's a bit like I don't know what to call it. It's a cabin, sort of youth hostelry type feel of a building. It's got a series of bedrooms. It's got the storeroom where we are at the moment, and it has offices, small kitchen area, showers, hot showers, sitting room, and lab space.
So it's actually really quite comfortable, isn't it?
It's a great way and base to explore the Arctic from, much more comfortable than living in a tent. And
I think something that's important about that is because this is a scientific research village station, and so this is set up with our food provided and hot showers and so on to enable the scientists to spend the maximum amount of time here working on those scientific projects. So if scientists had to spend a couple of hours every morning putting up tents, packing down tents, cooking on a stove, it's much, much harder, and you maybe have shorter time to actually go and get your data. So there are places, science research stations, that are quite remote, and you do have to do that. Here, because we've got the sort of comforts provided, the scientists can get on with the science as soon as they're awake, basically, can't they?
That's exactly right.
Okay, so on that same note, Mr. Curtis has also asked, do we get a break from the expedition to celebrate birthdays? That's St. Richard's asking.
Do we get a break?
Or what about Christmas or holidays? Can you just fly home and have a day off?
It depends. If you're here based for a long time, you do get holidays, and so you would be able to fly down to celebrate. I think certainly the weddings. People fly down to celebrate weddings. Christmas, if you're overwintering here, then you'd be here for Christmas. And birthdays, if your birthday was here, then you'd celebrate your birthday here.
And that would be quite good fun, wouldn't it?
Yeah.
Ice cream cake.
Ice cream cake.
Frozen polar cake.
Yes.
Yeah. And it's interesting you mentioned about overwintering, because certainly here, but certainly in the Antarctic as well, there isn't often the option to come home if you wanted to. There may be a period of a few months where once you're down there, you're then down there until the boat can come back and get you.
So, I mean, overwintering refers to the fact that during the winter period it's dark and it's cold, and I mean, not that it's dark all the time. From sort of October through to March, you get a glimmer of grey, smudgy grey at sort of both ends of that, and the same in Antarctica. And during the winter, sometimes can't get a plane in, you can't get a boat in, you're locked away, depending on what base you're on, by ice, and so you can be very, very isolated. You can't leave. And you have to be very self-sufficient.
But I think as well, it's quite a special place to spend Christmas. If everybody's there together, they all know, I mean, everybody's missing family and friends, so they kind of make a special day of it. We've had our station manager, Nick Cox, who we have a couple of interviews on our YouTube channel. He's told us some stories about spending Christmases or special periods in overwintering in either of the poles, because he's been doing that for
I think you have the midsummer is a big celebration down in Antarctica, because of course in the southern hemisphere Christmas is in the middle of the summer.
Yeah.
But up here, Christmas being in the middle of the winter.
And of course people have some chocolate and some special treats, or maybe even make some fancy dress and make a little party of it. So it's still a celebration.
Yeah.
Okay, brilliant. So sort of a similar related question from creating an environment here that's similar to home. DPS in India are asking, do you miss teaching in a regular classroom?
Wow, that's a great question. Do I miss teaching? I do miss teaching in a regular classroom, because I love that. As a classroom teacher, you can have a relationship with a group of students where you can see them develop over time and support them far more than sort of one-off, remote lessons from the Arctic. So I do miss that aspect of seeing young people progress and succeed at school. But on the flip side of, I do like being able to share these amazing places with as many young people as possible. So it's maybe difficult to mix those two.
Yeah, absolutely. And we've got a couple of questions from Mrs. Seymour's class. So we've got Adam, who's asked what's the coldest part of the Arctic, and also which is colder, the North Pole or the South Pole?
Great questions, Adam. I think that the coldest part of the Arctic is parts of northern Russia. I said it could get very cold. A friend of mine did a walk through Siberia, and it was so cold that the sap in the trees sort of expanded and the trees exploded. So he walked through an exploding forest, and then was talking to a local guy, and he was talking to this guy, and the guy's his nose fell off, froze and fell off, and he was looking at this gentleman in the middle of nowhere in Siberia, and was just looking at the ground. So your nose has fallen off.
And he presumably was so cold he hadn't noticed his nose had fallen.
No, he just said, "This is normal. This is normal." So there's some very, very cold parts of the world, and in terms of the North Pole and the South Pole is colder than the North Pole.
And why is that?
More ice.
More ice.
It's a big continent. It's a big continent of ice, and so it is colder down there.
Good fun fact for you there. And talking about things falling apart in cold weather and noses falling off, we've got a question from class 7F1 in Worksworth, who said, how do different materials act in the cold temperatures? So
they're rubbish. Rubbish when things get cold.
Bits of your body are falling off.
So plastic snaps, glue doesn't stick, things break. So it's absolutely rubbish when it's get cold, because everything becomes more brittle and breaks and snaps and glue stops working, and it is really, really hard. And we're talking about temperatures there, sort of -30, -35, and this is just boring. Uh, so things like you're trying to get some tape, just like electrical tape, insulating tape, or labelling some bottles, and you're just trying to take the tape off. And it's like having sellotape, and it's just becomes solid and just breaks again. Take my gloves off, can't feel my hand, breaks again, can't feel my hand anymore, can't feel my hand, breaks, can't feel my hand.
It's very tedious.
Very tedious.
And I mean, we're talking about this ski pole, the plastic handles of ski poles will just almost disintegrate. They just
I don't know. I haven't had ski poles in that part, in those kind of conditions. But it's quite fun. You can get, it's like a windsock. So we had built a runway for a base, a skiway, for the players to land. And you can hold the windsock and it just goes straight out like that. It just frees.
Just freeze solid. Yeah. Fantastic. So yeah, and it's something that's an emerging or a continual area of research, isn't it? Trying to design materials that can withstand the cold, and clothing materials that can be breathable and still warm and waterproof, but not, but allow moisture out.
Yeah, they haven't got as far as doing that for cable ties and tape. For some reason, I find myself going into shops every single year going, do you have duct tape that will work at -20? And I get very blank looks from people in the shops.
So if there's any emerging materials scientists who want to go into materials technology and design Jamie some cold-proof duct tape, that'd be very well appreciated.
Yeah, very much appreciated. Fairly niche market, I'm afraid, you'd be going into that.
Yeah, I don't think you'd sell many rolls of that, but the rolls that you did sell would be very appreciated. Yeah. Megan has asked in Mrs. Seymour's class, Megan's asked, what would you do if a snowstorm happened?
I'd make a cup of tea. Where we are, because we're in a research station, we have had storms here, some pretty brutal storms, and so we have just had to stay inside and and read books and drink tea. And going to get the milk was fairly brutal. So the milk is about 200 meters that way. And it felt like a full expedition, getting fully togged up. Goggles, face masks, sort of skidoo suits, walkie-talkie, sort of nearly had to rope up to get there. So it was really, really high winds, sort of beyond gale force, with the wind chills of -50 or something. It was really, really tough to get milk.
Did the milk taste good at the end of it? Was it worth it?
Yeah, it's a good cup of tea.
I'm sure there are several teachers watching who, if they had to go through that to get their tea or coffee for their morning break, would be struggling a bit, wouldn't they?
It's bracing.
Brilliant. Okay, so a couple of questions about animals. So on the live feed, we've got, where is it? Megan and Kim, who've asked what animals are in the Arctic, and also Iona, Flynn and Jamie from Taunton have also said, what wildlife and marine life have you seen?
Wow, so what have we got up here? Let's go for it. We've got beluga whales, we've got walruses, we've got seals, we have reindeer on the foreshore, we have scalpin, type of fish, Arctic cod, we have anemones, crabs, amphipods, copepods and krill, types of plankton. Then on terms of seabirds, we have little auks, fulmars, and eider ducks. We also have around here somewhere an Arctic fox, which is being a little bit elusive at the moment, and there will be some polar bears in the area, but luckily quite far away from us at the moment.
Gosh, wow, what a rundown. Very comprehensive list there of Arctic wildlife. So fantastic. And we have got a video up on our social media feed as well of a reindeer that walked just past our base the other day. So do check that video out and you'll see what the reindeer is like up here. Okay, fantastic. Moving back over then to the pre-submitted questions. Staying with Taunton, we've got Lilla has asked, what kind of activities do we do during the day?
Basically 2 or 3 activities. We're either doing science, and that's normally out on the boat sampling. We might be doing a broadcast to share what we're doing with schools like yours. And there might be sort of this organisation, so planning what's going to happen at this, how do we get the samples back, Do we have enough milk? Those very, very important questions up here in the Arctic.
Brilliant. We've also then got from Hawkley Hall High School in Wigan. Elliot and Frankie want to know, can we physically see any changes that show the effects of global warming?
You can see changes due to global warming. Those changes aren't just to sort of like pop your head out the door and have a look and go, oh look, it's global warming. It's more what's happening over longer periods of time. So you'll see here that there is far less sea ice in the fjord than there used to be. You can also see that the glaciers have retreated to such an extent that what used to sort of people thought was a headland is now an island as the glaciers have retreated.
Okay, great. There's a few questions about one, have you seen a snow owl? And Kim is asking, have we ever saved any animals?
We haven't seen a snowy owl. I'd love to. Such wonderful creatures. Have we saved any animals? It's a difficult question to answer. We're not up here as vets, so that's not part of our job. Actually, we're normally taking animals out of the ocean and analysing them for how environmental changes are affecting them. And those are the smaller animals at the bottom of the food chain, the sort of krills and the crabs of this world. And that's to see how human activity is affecting this part of the world. So in a roundabout way, if we can show how human activity is affecting these animals through the research, it might be that individuals or governments decide to make changes, and those changes can help to save the ecosystem generally, rather than sort of being the sort of like the sort of mission vet type thing.
Sure, fantastic. A few questions on the live feed about the base. There is a question from Tiamat about what's the base like. I think we answered that at the beginning, so perhaps you can look back and see there. But Harry wants to know, how long will we be at the base? And also there's a question about how do we get supplies in and out? So Harry, we're here for 2 weeks, and people can be here from probably the shortest time for research is 2 weeks for us, sometimes 3, 4, 5, 6 weeks. Then people are here for several months, and also people live here full time. There's a lot of support around this, so people who operate the kitchens, the support, the power station, the boats, the harbour, that kind of thing. And just referring to the harbour there, that's where most of the sort of larger goods come in, although it's possible to bring in some via plane. And a question from Hawkley Hall, Beth and Sophie have said, what about internet? Have we got Wi-Fi? How are we broadcasting?
We've got awesome internet here. It's probably, it's definitely faster than I have at home. We're on a sort of pretty fast fibre optic link, and that's linking us to the mainland from Svalbard. The reason for that is there's a lot of science data going back from here, but it is definitely not Wi-Fi. And that is because Wi-Fi signals, phone signals, Bluetooth all interfere with the sensitive scientific equipment that we have up here. Okay,
a couple of very quick questions. How do you prevent slipping on the ice?
Crampons. Crampons is spiky bits you put on the bottom of your boot or shoe.
Megan wants to know, does your mood get affected in the cold?
I can be a little grumpy when it gets super cold, yes.
Mr. Curtis, how do you sleep even though we've got 24-hour daylight?
Blackout blinds.
Very clever, very useful. If you didn't have those, I suppose you could wear...
I've turned my big furry hat the wrong way around.
Put your hat on backwards, blackout, anything to block it out. Brilliant. We've got lots and lots of questions coming through on the live feed. We're not going to have time, unfortunately, to answer all of those, but we are coming back for another Ask Me Anything with Jamie later on this afternoon or this morning or this evening, wherever you are. There was a question about time difference. What's the time difference between here and London, for example? Here in London, we are 1 hour ahead. We're on Norwegian time, so that's currently GMT or UTC +2, with the UK +1.
and the east coast of the US -4 at the moment, I think.
Okay, so we will come back and we'll try and answer all of those extra questions. But just to finish off with one final question from the pre-submitted. This is from Leah from Hawkley Hall High School in Wigan. A bit nice final question. What are we going to do by 2050?
So Leah, what are we going to do by 2050? We'll be living wonderfully in harmony with our planet and being nice and kind to each other. So that's what we're going to be doing by 2050, and that work has already started and needs to carry on even faster.
And it's all up to all of us, isn't it?
Up to all of us
to make sure that reality, that picture of 2050 comes true.
Yes.
Fantastic. What a lovely way to end there.
Yes.
So I'll pop back behind the camera and Jamie will tell you about the remaining sessions we've got coming up.
Thank you so much for joining us on XL Catlin Arctic Live. Remaining today, we have a live investigation looking at how different types of ice can affect sea level rise. So we've got a bit of iceberg just outside the door for that. We have another interview with Ellie Mackay, and that will be in about 3 hours' time, and then a final Ask Me Anything open Q&A, and that is in fact, very sadly, our final session on Arctic Live for this year. So we look forward to seeing you online later. Please do post any photos, any comments on our Twitter feed as well. Hashtag Arctic Live, and very much looking forward to seeing you later, and thank you so much for being part of this session today.